Stephen should be recording now. So even if you don't like your grades, for whatever reason, maybe it brings your GPA down or whatever, there's this credit, no credit option, which, if I thought that this course was going to hurt my GPA, if I wasn't, an international student, a student on some kind of a special scholarship or something like that, or on probation, one of those categories, I would consider maybe doing that. Might be seems like a good deal. Okay, so here we are. We have to look pat ourselves in the back. We're all the way to April 30th. Yay! Let's see, assignments. So I've updated this assignment page. Before I had here pods, which is like an earlier version of the project. So I changed it to SmartBox. So SmartBox is kind of a slicker version of pods. And that's going to be sort of the focus of today's lecture, and I'm going to help you get started on that. And then also, if you click on lectures, refresh this page. Okay, and come down here to container component architectures and maybe refresh that page. So I updated this. Oh, and the grades, you need to refresh that. I had 55% there, so refresh it should be 60%. Okay. So where am I? Okay, so I'm here, open architectures, component-based development. All right, so hopefully you're there too. So let me say a few words of motivation here. So component-based development is a style of programming which is kind of akin to object-oriented development. Right? So you're all object-oriented programmers, and now I'm going to tell you about component-based or component-oriented programmers. So my motivation for this, or one thing that this is in my imagination, of course, nothing was based in any actual knowledge of my part, but my vision of what a hardware engineer does is he's like a guy who's at a workbench. He's got all these bins with chips in different cubbies in the bins, and he's got in front of him like some kind of like a motherboard, and he's pulling these chips out of the bins, and he's soldering them into this motherboard, and voila, you've got like a computer or whatever. And I think it'd be cool if software development was like that. If we had little bins, and in there, we had software chips, and we would plug them into, instead of a motherboard, we'd have like the software equivalent of a motherboard, and that's how we would build software. Well, that in a nutshell is component-based development. The software chips are called components, and the software motherboard is called a container. Okay, and so if that's the way that you program, then you are practicing what I'm calling component-based development. Okay, and let me give you some examples of that. One example is Visual Basic. So Visual Basic, you have on your screen, you literally had something like cubbies on the right side of your screen. On the left side, you have a container, right? Just this big blank screen. And you have components in there like a calendar control, a calculator. And you could drag these things into the left-hand side of the screen, and you could connect them with little wires and so forth, and boom, there's your application. Another example of this sort of thing is we have these J2EE, that's Java Enterprise Edition. We have SE, the standard edition. There's an Enterprise Edition, and it has like this web server in it. Used to have a web server in it called Tomcat, the J2EE web server, it's probably called now. And what you could do is you could drag these components in there to the web server called servlets, and you could customize that's how you would build web applications. Now, some of these web applications require some back-end support. So they had what was called an application server. And it used to be called JBoss. And it had these components. Well, that's what Java beans were invented for. Those were the components. And you would drop them into JBoss. You could build like like an insurance application, a medical application, whatever the business logic is would go in there. Okay. And now, of course, like if you are, say, like a fairly big company, probably like maybe Fortune 500, maybe not that big, you need some pretty serious software to run a large company. You need human resources, inventory management, shipping, logistics, e-commerce, lots and lots of applications to run this thing. And what's worse is that you need these applications to be able to talk to each other. They need to be integrated. And, back in the bad old days, that was a really tough job, right? Because these applications all came from different vendors, and there was like no reason why they would be able to talk to each other. And so you needed like hire a really smart guy to get in there, write a bunch of code to get these different, to get HR talking to payroll, getting payroll to talk to your accounting package and so forth. And there was a lot of like gluing these pieces together. It was really hard to do. Now, companies like SAP, Salesforce, they give you this container and they give you these components. You have to buy the components. The components are expensive, so maybe you can't afford all of them, until you get rich. You buy what components you can, you drag them into the container, and they just, start talking to each other. It's very easy to do. Open architecture too is like sometimes goes along with this. So if you're a company developing one of these containers, do you want your customers to buy just your components, or do you want to open up a market, create a little market for third-party components? Okay, so there's like a whole business debate about that. This is the debate between Apple and IBM when microcomputers first started becoming commercial. Even today, Macintosh has the proprietary, or Apple has a proprietary architecture. So if you want a component for your Mac, you have to go to the Mac aisle and you have to buy, like the component is either built by Apple or built by one of their licensed vendors. And they're usually not competitively priced, usually quite expensive. On the other hand, you want a component for your PC, like a speaker or something like that. Well, there are miles, go to Fry's, there are miles and miles of these aisles for these things. Yeah, and they're all competitively priced. You have a choice of 20 different speakers that you can connect to your PC. You open up the PC and there's a little plug-in card and you plug it in, and away you go. And those speakers are competitively priced because they're developed by third-party vendors. And you think, I know I went through this many years ago. I was like an early adopter for the Mac, but then, I'd go into Fry's to get like speakers for it or whatever, graphics card. And they were really expensive and there weren't many choices. And I'd look over and go, well, how come PCs, have 10 aisles of these things and they're cheaper? Well, it's because IBM published the architecture of the container. So a third-party guy could know like what kind of card you need to build in order to plug into this thing. And that's called an open architecture as opposed to a proprietary or closed architecture. And it drives sales, right? You don't make money off of these third-party components, but your container application is more popular because there are so many available to your customers. All All right, so I don't want Eclipse, of course, champion container component architecture. You know, probably some of you, when we're doing your team projects, noticed that there was a Git plugin for Eclipse. You know, when they designed Eclipse, and by the way, some of my former students were leading the design team for Eclipse, students from the precursor of this class. They designed Eclipse as a container, right? And you know, virtually everything in Eclipse is a component, you know, a plug-in component. Plugins are a type of component, so most browsers use some sort of container component architecture. Here's some informal definitions. So internally, a component is a runtime collection of encapsulated functions and data. So let me just unpack that for you a little bit. So runtime, well, I mean, a package is a collection of functions and data. Okay? What's the difference? Packages only exist at compile time in your program. Okay? They don't have any existence when your program starts running. So component is a runtime phenomenon. It's very similar to the distinction between class and an object. An object exists at runtime. It's an instance of a class. A class exists at compile time. Another thing to unpack here is the term function. So I make a distinction between a function and a method. Okay, and that distinction is that a method has an implicit parameter, whereas a function doesn't. For example, consider like the withdraw method for a bank account class. Okay, so to call that, you'd have to call, you know, like my savings account dot withdraw 50 or my checking account dot withdraw 50. So there's the object who's executing the method, the code that goes on the outside, my savings account, my checking account. And so you can consider a method as describing an object behavior. Whereas a function is something like, you know, the sine function, sine of x, right? Well, it's not describing a behavior of some object. Okay? It's just a useful function. There is no this parameter, no implicit parameter. So these can just be functions here. Okay? On the outside, a component is a set of realized interfaces together with a set of required interfaces. So realized interface, well, what's an interface? An interface, you can think of a Java interface. It's a set of related operations. Operations, again, are methods without code, abstract methods. Attributes, and receptions. Receptions are listeners, like they listen for events, like we have property change listeners, action event listeners, and same thing here. And so a component, the realized interfaces are the interfaces that that component implements, the services that it provides. Required interfaces, those are the interfaces it needs somebody else to provide for it. So UML has a notation for component-based developers. This is what a component icon looks like. And then this is where we use circles for interfaces in UML. Okay, so component one realizes or implements interface one in this diagram. Component two implements or realizes interface two. Sometimes these realized interfaces are called lollipops because they look like lollipops. This guy here, a little stick with a socket on the end, they're called sockets. That is a required interface. So component one requires somebody to implement interface two for it. It needs that. And here we can plug a lollipop into a socket here to indicate that component two comes along to the rescue. He's going to implement this interface two needed by component one. This is actually old UML notation. UML likes this new notation here, where instead of the tabs here, they have a little picture on the inside. I don't like it. It's very hard to draw these things by hand. So I just prefer to do it this way. So what's the difference between component-based development and object-oriented development? Well, components are a very high-level view of a program. The components usually represent, something like a subsystem or a collection of related services. When you go inside of a component, you might find in there objects that implement that component. So objects are a more refined, detailed level. And component-based development goes on top of object-based development, although you can do component-based development in a non-object-oriented programming language. But for our purposes, these components are kind of higher level sort of things that are built out of the objects. Here's some more details. So here we have component 1, interface 1, it provides interface 1, it requires interface 2. So collaboration, we talked about collaborations before. Collaboration is a collection of objects that interact with each other in order to achieve some purpose. One of those purposes is to implement a component. So this is actually a UML diagram. They actually have a notation for a collaboration. And here this is indicating that collaboration 1 implements component 1. Okay, and when you look inside of this collaboration, you might find a sequence diagram showing you the nature of this collaboration, how they interact with each other. You don't need to know this, but just to understand it. So this sequence diagram might be what's going on inside of this collaboration, showing how some objects pass messages back and forth with each other in order to implement this component. So a component has a collaboration inside of it. What about the container part of component and containers? Okay, well, let's go back to this picture for a moment. So these components are things that are in my little virtual workshop in the bins. I'm dropping them into the container. So let's say that I drop component 1 into the container. So somehow the container has to, first of all, the component has to announce to the container, hey, I provide interface 1 in case anyone needs it. Then it also has to ask the container, hey, listen, I need somebody to implement interface 2. Is there anyone here who does that? And the container might say, just a minute, let me check. Oh, yeah, I've got component 2 over here. He implements it. Just a minute, let me hook you guys up. So that's what the container does, as well as provide an execution environment, communication services, serial persistence services, things like that. But this service that I'm describing is called discovery, right? How does component 1 discover component 2? It could go in the opposite order. Component 1 gets added first. Does anybody implement interface 2? And the container might say, sorry, not yet. And then when component 2 comes along, gets dropped in the container goes, hey, wait a minute, you implement interface 2? Yeah, I've got a guy over here, component 1, who needs that. Let me hook you up. And so that's what the container does. Let's look at some examples. Okay, so an app server. So this is a typical web application we're looking at. Web browser, web server, enterprise Java Bean server, and database are all of the components. The web browser provides an HTML interface. So if you give it some HTML, it'll display it for you. Okay, but it requires somebody to implement an HTTP interface. And that's exactly what a web server does. Web server needs somebody to provide business logic, though. Web server knows about serving up web pages. It doesn't know, for example, like, how to calculate premiums on insurance policies, for example. So it needs somebody to do that. And EJB server, the way that it presents business logic, these two interfaces called session bean and message bean. These are two specialized kinds of beans, the same Java beans that we've been talking about, but a little more specialized. So it provides these beans for the web server. Your business logic is going to go into these kinds of beans. But the EJB server doesn't know about your data, right? It needs a database for that. And here the interface would be an SQL interface. So there's a component-based diagram showing how to put together a web-based application server. Here's an e-store. I've got a cart component and a credit card component. Cart component provides an interface manager per cart, probably add to your cart, remove from your cart, checkout. And I need these interfaces: transfers, search, ship, and credit card, a debit interface, which the credit card provides, assuming that somebody provides a banking interface for the credit card. Insurance, I've got underwriting services, risk assessment, policy database, claims, accounting, billing. Those would all be the components. And you can see I'm wiring them together through these interfaces. Human resources, hospital management, patient billing, patient management, medical records, clinical decision. There's inventory management. I've got inventory, warehouse, and shipping. Order fulfillment interface, implemented, provided by warehouse, and required by inventory. Shipping interface, needed by the warehouse, provided by the shipping component. Now, here's another way to think about it. Let's look at this diagram for a moment. I used star UML to create this diagram. But imagine this, and this would be like a good project for, I think, like a master's thesis maybe. Imagine this. It is possible to customize star UML. Imagine all of these components that you're seeing here, okay, were predefined components. These icons are representing actual components that, actual patient billing components. Okay, so I want to sit down at star UML. I've got, just been hired as the IT manager for some big hospital, let's say, and they need some enterprise software. So I sit down at star UML and I create this diagram. Okay, but this is a customized version of star UML. So there's a special button called deploy. And when I push the deploy button, okay, the actual components actually wired together in the way that I've shown here are deployed to the hospital server. Okay, and boom, the application is up and running. The components all do different things, but they talk to each other through these interfaces. That is basically, if you're like in the business school doing MIS, managing information systems, building information systems, this is basically what you're doing here. You are creating these applications by using component-based development. This is what component-based development looks like. You're essentially creating something like a UML component diagram, but that thing is deployable. Right? So this is your understanding of like the hospital enterprise software system, which you've designed by just this nice little drag and drop interface that we have here. So that's component-based, one way of thinking about component-based development. And how cool is that, right? I mean, it's so easy. It could be so easy to do. Okay, let's all take a breath. Right. So what are we going to do? We're going to build one of these things. I call it SmartBox. This is SmartBox version 2.0. I've been thinking all semester long about this. I had this SmartBox container component system for my graduate course. It was too hard for the undergraduate course. So I've been thinking all semester, like, how can I make this easier? And so I think I've come up with a pretty good way of doing this. I'm calling it version 2.0. Okay, so let's talk some more about CBD, component-based development, but this is CBD using SmartBox. So in SmartBox, we're imagining 4 different CBD roles. Okay, there's the container developer. Okay, this is the smartest guy. He's the guy who's going to build the container. The container is called SmartBox. So he's going to create the container class and the component class. And this guy is going to have to know an awful lot about Java reflection to do it. Then let's go over here, component developer. So this is the second smartest guy. Right? He knows how to create components that work with SmartBox components. So he might create like a calculator component, a calendar component, things like that. He knows how to build these components. Next, let's go over here. There's the app builder guy. Okay, now the app builder guy, he's the guy who buys the container from this guy, he buys the components from this guy, and he plugs them into the container and connects them together. In other words, he's going to actually build some kind of an application. And then way down here we have the app launcher. He's the guy who uses the application. I think I have an example. So company A is the container developer company. Okay, they sell to company B, who creates enterprise components for logistics, accounting, HR, e-commerce. B resells the container and several components to company C, which sells vacuum cleaners. The IT guy at company C deploys the components into the container. He's the app builder. And then finally, the sales rep at company C, he's the app launcher. He uses the components to arrange shipping of a vacuum cleaner to a customer. So those are the roles. We're going to be playing all 4 roles here. They could all be the same person. They're roles, right? But we're going to try to keep in our heads which hat are we wearing. Here I've showed like a few use cases for some of these roles. Okay. So how do you customize SmartBox? And when I say customize SmartBox, it's like customizing in the way we've been using the word, like with frameworks, but there with a framework like MVC or Echo, customization happens at compile time. You have to write a bunch of classes. And here, the customization happens at runtime. You're just going to be dropping these components into the container at runtime and building your application that way. Okay? So I think that's amazing. Hopefully, you're thinking to yourself right now, wow, how is that even possible? And the answer, by the way, is reflection. This is what reflection was developed for. Okay? The component developer is going to define some interfaces for her components. Okay? The interfaces that her component will implement. Okay, and she's going to create implementations of these interfaces. Okay, then she's going to create classes or other classes that she might create that are going to require these interfaces. All of the classes that she creates must extend the component class in the SmartBox component class. The class that launches the application, there's a special interface called app. It just has main in it. And that's a launchable component if it also implements app. Here's an example. So statistics calculator. So I'm going to create two components for you, calculator and statistics calculator. Here's this interface called iCalculator. Okay, and it's a pretty simple interface. It's got add, multiply, subtract, divide. Okay, my calculator class implements this interface, and stats calculator class uses something that implements this interface. So it has a pointer to something that implements. It's now very important here. Stats calculator and calculator don't know about each other. There's no direct connection between them. So it's possible that calculator component was developed by a different company than stats calculator. So these guys don't know anything about each other, okay? Stats calculator also implements the app interface. Now, app interface is in SmartBox itself and just has one method in it, main. You should provide a main method so we can launch you, okay? And so, and now part of the requirement is, okay, well, if you're going to use SmartBox, you have to extend components. So both calculator and stats calculator extend component. So that's the sense in which they are components, SmartBox components. This is the component diagram version of this. Calculator, stats calculator, they are components. You can tell by their icon, so they extend the component class. Okay, and here's the iCalculator interface. It's provided by calculator and required by stats calculator. Okay. Right. Here's a screenshot of SmartBox. So this is SmartBox. Okay, you can see here it's got add, remove, and run buttons. Same thing under the edit menu. You can probably tell by looking at it that, oh, this is an MVC application. It is. And this is what it looks like just after. This is now the app builder. So I am going to be the app builder. I'm going to build this app for you. I click the add button, and I've used that to add the calculator. So we see the calculator in there. I'm going to click the add button again, and I get this little thing. What's the name of the component you want me to add? And I typed in stats calculator, and I hit OK, and now this is a screenshot. So you see the stats calculator is in there. Okay, then I'm going to hit the run button. So now I'm changing hats again. I'm now going to be the app. What do I call him here? App launcher guy. App launcher clicks on run. It says, what do you want to run? And he says stats calculator. It calls the stats calculator main method, which computes the average of a list of numbers and prints it in a little box. This one doesn't do very much, but supposed to be simple. Okay. So let's look at the code for this. And now here's the question I want you to keep in your mind when we're looking at the code for this. The goal of the container developer is to make the life of the component developer easy. Why does he care about this guy at all? Right? Well, the reason he cares about him is that is his customer, right? And if he can make his life easier, then his customer will like him more. And if his customer likes him more, his customer will give him money. Okay, that's easy to understand, right? So the question to be asking yourself as we look through this code is, how complicated is this code? If I was going to buy SmartBox from Professor Pierce, what would it be worth to me? How hard would it be to customize it? Okay, so if you want to build this app, okay, these components, this is what you have to do. Step one, you have to create the iCalculator interface. Boom, there it is. Pretty easy. Nothing to implement, you're just declaring this is what, what I wish somebody would implement. Step two, you have to implement the interface. So here's calculator. Okay, now here you can see a few things about this. Well, let's look at the code. Calculator extends component. Okay, so that's something that you read in the SmartBox user's manual. If you're going to create a component, extend the component class. Oh, you might ask yourself, what does the component class do? And there, if you turn the page on the owner's manual, the user's manual, it says, don't worry about it. That's nice. And then implements iCalculator. So I don't even have to understand what component is, right? It's not, I don't need to worry my pretty little head about that, okay? And then here it is. Presumably the reason I'm building this is that, my expertise as the component developer here is math. I don't know anything about components and containers and architecture and so forth. I don't need to know that, right? So my life is easy. My life is good, right? I do need to know about how to do basic math. Well, okay. That is something I can do, right? So there's the implementation. Now, a few other things here to look at. So I've had to import component from SmartBox, so I needed to do that. The other thing is that, that it says in the user's manual, this is like what made things so much easier for this version 2.0. SmartBox requires that all components live in the component subpackage of SmartBox. Okay, so all of your components live in this package. And it's a bit of a restrictive thing. It's actually not that unusual though. Okay, for a lot of containers, for example, all of the web apps that your web server is going to run, those web apps have to live in a particular place, have to live in a particular directory. So it's not that uncommon to require that all of your components have to be deployed to this particular directory. And so they all are part of this package, smartbox.components. Okay, so that's not too bad, I don't think. Then finally, stats calculators. Remember, this might be a different guy here. Stats calculator extends component. Again, I don't really have to understand what component is. And implements app. Uh-oh, that sounds hard. No, implements app is just has this method in it. This is just to launch your component. Okay. I meant to do this. These two methods here are not needed. Shoot, I was going to get rid of those before lecture started. Oh, well. So they're not needed. So just ignore those. I'm going to get rid of those. Here's one statistical method called mean. You give it a list of numbers, a list of doubles. And it's going to add all of the doubles together and then divide that sum by the size of the data set. Okay, now it's curious here, you know, I'm a statistician, I guess, developing this. So I know how to compute means of lists of numbers, but I don't know how to add or divide. But okay, just go with me on this. Okay, so I need some help on doing the arithmetic. So I'm going to assume, coming back up here, that I've got some kind of an arithmetic calculator, okay, something that implements the iCalculator interface here. I'm going to assume that, you know, that exists. And I use that arithmetic calculator here to like add up like all of the things in this, all of the values in this data list. And I'm going to use it again to divide that sum by the size of the data list. So I require the iCalculator interface to be implemented. It's a need that I have. Now, it also says in this imaginary user's manual that, that this field should be public. Okay, so if you have a field, a public field of type interface, that means that's something that you require. On the other hand, if you implement an interface, that's something that you provide. Okay, so I think that you should agree with me that that's pretty easy to do. If you're a component-based developer, I mean, you might have to know lots about math. I mean, that's not my fault. But you don't need to know very much about components and containers. You need to extend the component class. You might need to implement the app interface. Okay, you need to know how to push these buttons. You need to put your stuff in a special directory. But you can, we're going to build like a much more complicated application than this later on. So pretty easy to do. And this application is being built at runtime while SmartBox is running. Okay. So we've just looked at the life of the component developer. Okay? And it seems like it's a pretty easy life. We're now going to look at the life of the container developer, the SmartBox builder. That's going to be a little bit more difficult of a life, but not that difficult, I think. So let's talk about the design of SmartBox. It's an MVC application, as you probably guessed. So here's SmartBox. It's a package that depends on the MVC package, which depends on Java, obviously. Here's components here. This is the package where all of the components will live, okay? And that depends on SmartBox, okay? Just as we saw here. Calculator, stats calculator, extend component class. So here in SmartBox, we're gonna have the class component and the class container. And here in components, you'd have calculator, stats calculator, iCalculator. Here's a class diagram of, this is what's inside of SmartBox. Here we have the container class, and this extends model from MVC. The container has a bunch of components, 0 or more components. Notice that this association is bidirectional. So the component knows about its container. Okay, here's the app interface up here. It just has main in it. Component is going to have to be serializable. Okay, this is very similar. This arrangement here is very similar to simulation, which was a model. And had a bidirectional association with agents, which were serializable. So it's the same basic shape, the same basic pattern. The container is going to manage the components just as a simulation manage the agents. A container is going to provide discovery services to the components, just as the simulation provided discovery services to the agents. There, it was get neighbor. The agent needed to know, are there any neighbors nearby that I can interact with? So it's a similar sort of thing. Component, here are the provided interfaces as 0 more provided interfaces and 0 more required interfaces. And this is where reflection seeps into it. So we talked about reflection. Let's see if I can pull up those notes. Scroll to the bottom here for a second. Remember we talked about reflection last week. Every object has this get class, and there's this class. Okay? Now it turns out that, back up to the diagram here. Turns out that reflection doesn't have a special class for representing interfaces. Okay? An interface is represented by an instance of class. Okay? You can tell when an instance of class represents an interface, because in class there's a Boolean valued method is interface. So you can just say some class dot is interface. Is that true or false? So even though this is showing in the diagram as a list of, as a collection of classes, it's actually a collection of interfaces. And then over here, the required interface. So this is a collection of interfaces too. And then here, this is also from reflection. Remember, we have like a class called field. And I think we saw that. Here, for example, get fields returns an array of objects representing fields. So it keeps track of all of its fields as well. So now let's go ahead and talk about how we're going to implement this. So let's start with component. So here's what the code looks like. Here are the fields that are in the component class. So here's the required interfaces. This is a set, and it's a set of classes. Okay? They're actually a set of interfaces, but like I said, we don't have an interface class. Here are the provided interfaces, a set of classes. The interfaces that the component provides, the interfaces the component needs or requires. Let's go back up to the, I guess it was on like the last page. Let's see if I can do this. All right, so component one, it's just going to have one interface, and its provided interface is interface one. It'll only have one interface, and its required interface is interface two. Okay, it also, here's the reference to its container. Right? That's this endpoint here. And it has a name. Okay. For example, here is the stats calculator. Okay. It extends component, it is a component, and it has this field, this public field, arithmetic calculator of type iCalculator, and it's public. That means that iCalculator is a required interface for stats calculator. It needs somebody to come along and implement this interface for it. And by contrast, calculator class implements iCalculator. So iCalculator is a provided interface for calculator. Calculator provides the iCalculator interface. Stats calculator requires the iCalculator interface. Right? And that's this picture. That's this picture here, but in code. Now let's talk about the container. The container has inside of it 3 tables. Provided interface, so this is a table that lists all of the interfaces that the container knows about and what components implement those interfaces. Required interfaces, this is a list of all of the interfaces that the container knows about and who needs those interfaces implemented. And components, this table is just the name of each component and the associated component. So turn on speaker view for a moment. This is a little diagram I drew for the last class. Hopefully you can see this. So this is what's going on inside. Hold it still for you. This is what's going on inside of my container class. So you see these 3 tables. Okay, down here is the component table. It's got the name stats calculator and calculator, and they're associated with the stats calculator component and the calculator component, just so you can look them up by their name. Up here is the provided interfaces table. Okay, so the interface here is iCalc. Okay, and the hang on a second, sure I've got it backwards. Sorry, just give me a moment. Yes. Sorry. Get this right since we're taping. Okay, let me try this again. So provided interface. So here's the interface column. There's a row in there. iCalculator is the interface, and calc is the component that provides that implements that interface. Over here in required, iCalc is in the interface column, and stats calc is the component that requires it. Okay. And then down here, we have calc and stats calculator, and these are their string names. So when you add a component to the container, okay, the first thing that happens, we've added this component, we set the container for the component to this. Next, component, this is the components table. We're going to put a new row in there. Here's the name of the component, and then here's the component. Next, we're going to update the provided interfaces table. We'll see if you can understand this code. So here's the component that's being added, and I'm going to say get provided interfaces. Okay, so those are all of the interfaces that this new component provides, and now I'm going to iterate over that. So INTF will be each interface that it provides. There could be multiple. And in the provided interfaces table, I'm going to put a new row. This interface is going to be provided by, implemented by this component. I'm going to do the same thing for the required interfaces table. You're going to do it. And it'll be very similar code to this. Next, after so this is what happens when we add a component to the container, right? We do this, we do this, we do something similar for the required interfaces. You have to write the code for that. And then finally, we do some matchmaking. So the container goes through these two tables and it sees, is there any interface that's required by somebody that's also in the provided table? And so he would look over these tables and the container would notice, wait, I've got iCalc in both tables. iCalc is required by Stats Calculator, and I see that iCalc is provided by Calc. Hey, I'm going to wire these guys together. Okay. And the way that he's going to do that is here he's found C1 is an instance of class capital C1. That requires interface 1 because it has a public field of type interface 1. That's how I know. And here is C2 is an instance of C2 which implements interface 1. And so what I'm going to do is C1.setProvider interface 1 C2. That's going to be the code that marries them together. Okay. So what I'd like you to do right now is, if you haven't done this already, is start up Eclipse or IntelliJ. Okay? And I'm going to go pour myself some more water. And while you're doing that, I'll get water. Oh, that was probably pretty loud. Okay. So let me take a look at my IDE, which is here. So what I've got here is, this is my MVC apps package. Okay, here's MVC in here. And I have SmartBox in here. If you open up SmartBox, you've got, here's component, here's container. I've also got this sub-package, SmartBox components. Look, here's calculator, iCalculator, Stats Calculator, they all live in there. Okay, so what I want you to do is to, wherever it is that you keep your MVC applications, you're going to go in there and let's see, right click on the source. You're going to add a new package. I also got a cookie, a very old Girl Scout cookie. The Girl Scout wasn't old, the cookies are old. You're going to create a package called SmartBox. I'm going to call mine SmartBox 3 because this is section 3. Just call yours SmartBox. Okay. And then I'm also going to right mouse click on that package. And I'm going to create a new package, SmartBox3.components. So that's where I'm going to put all of the components I developed. Probably pretty gross watching the cookie. Now, right mouse click on SmartBox 3. I'm going to add a new class there called component. Now we're going to go back to the web page. I'm going to click on, oh, I got this backwards, my components. I'm going to copy that. I'm going to paste that code in. Change my package to SmartBox 3, but save it. Let's do it again. Right mouse click on SmartBox 3, a new class called container. Back to the website, container.java. Copy that. Paste it in. Should be an easy 5% for you. Right mouse click on SmartBox 3, a new class called container panel. Panel. Paste it in. Save, save, save. Okay, you're on your way now. Let's start with container panel. So this code is complete, okay? Sort of complete. First of all, one thing is there is no view here. Okay, there's no view class you need to implement. Instead, I'm using an old list control. So that's what you saw in that picture I showed you. I'm using a list control. It's just going to simply list classes in there. Here, container factory. So I haven't implemented that yet. That needs to be implemented, but that's pretty straightforward. And then you'll need your commands. Those are missing as well, but look, add, remove, run. Those are your commands. So you're going to need 3, an add command, a remove command, and a run command. Remember, this is MVC. Oops. Let's look at component. Okay, so components. See any errors in here, but so component. So here are the fields. Okay, so this would be the type of the field, the class, the interface, and then this is the Java reflection object field. Okay, so those are the fields. You know, like for example, stats calculator has like a field called arithmetic calculator of type iCalculator. So that's going to go into this fields table. Here is the provided interfaces. That is a set of class objects. Okay, remember, class objects can also represent interfaces. Same with required interfaces. Constructor initializes all this stuff for you. And here are here's what I'm going to do. So you're going to have to fill in some code here. Initialize fields and required interfaces. So compute required interfaces. So this .get class, what is the class of this component? Let's see, maybe maybe it's stats calculator. Get declared fields. Well, there was only one field in stats calculator. That was arithmetic calculator, but there could be many. And so we're going to get an array of fields. Now we're going to iterate through this array of fields. And for each one of these fields, if that field is an interface, then we can assume that that's a required interface. We're going to add it to the fields table. This field is of type this interface. And we'll add whatever interface that was to the required interfaces set. So you have to finish that code. Here's compute provided interfaces. Okay, so in this case, what you're going to have to do is, you'd probably start out similarly to what you did before. You would have to do to get the class of this thing, okay, and then you'd have to get, let's see if they have it. Look at that, get interfaces, boom. Right? So you go through these interfaces and you're going to take each interface and put it into the provided interfaces. Those are the interfaces that it implements. It's easy. And then here's this set provider method. This is implemented for you. And this is like where that magic happens, right? Here I've got a provider that implements this interface ITF. So I go to fields table and I say, what field needed that interface? Here's the field. So then I'm going to set the field for this object, this component, to this provider. That's how they get wired up. That's like kind of the most magical part of this. Finally, here's the container class. Container class, here are these tables that it has. Okay, here I'm going to add a new component to the container. Now, when you click that add button, you type it in, it's just a string, it's the name of the component. Okay, and so I'm going to assume that that name, like let's say that it's calculator, I'm going to assume that it's in the SmartBox.components package. And so I'm going to make the qualified name by prepending that package name to calculator or stats calculator. Next, I'm going to make a new instance of the class. So I'll have to load the class in. Right? You have the class name. So, you can load it in. We did this for the request handler. And then you can create a new instance of it. Look at your server code to see how to do that. The lecture notes. And then add a component. Then I'm going to call this add component down here with this new component object. So this is a private helper function. Okay, it takes a component as an input. It sets the container to this container. Okay, here's the components table. It's going to put in there. Here's the name of the component, and here's the component with that name. This is the code we just saw. It's now going to update the provided interfaces table. So this interface is provided by this component. And this is for all of, you do this for all of the provided interfaces, this component. Then you're going to copy this code. Only this is going to be the required interfaces. And this will be the required. You get the picture. And now I call find providers. So this is the matchmaking stuff. And after I found the providers, I wired everybody up. Well, we are container extends model. We're an MVC app, so we're going to call changed. And that's what's going to update the that list. Here's remove component. I think that's fully implemented. Find provider. So this is fully implemented, but I want you to understand this code. We'll go over it next time. And then launch. Here's the name of the component to launch, stats calculator, for example. You look up the component and you check to make sure that it implements the app interface. And if so, it should have a main method in it. And so you call its main method. Okay. All right. I am out of time. What I'd like you to do is I'd like you to get that code running and then test it with the stats calculator that I gave you. Right? You get that tested and get all that done by Tuesday. Okay. And then what we're going to do is we're going to build like kind of a cool components for it. Stack machine customization. And so this is what we're going to now be component developers. And we're going to put together this component diagram. And we'll do that on Tuesday. After you've tested to make sure that you can do like the calculator. One, and I've given you a bunch of code, of course, for that. Okay. If you have questions, so you can do maybe quick questions now. Get required interfaces. Yes. Yeah, I've left out a bunch of getters and setters in there. So yeah, there's some small amount of code you have to implement. Get this running by Tuesday. The assignment will be due on Thursday nights, a week from tonight. But we're going to devote all of Tuesday's lecture to writing this, trying to get this stack calculator example working. And then Thursday will be the review for the final exam. Okay, and I have an office hour Friday, and I'll have an office hour Monday. All right, listen, I have a department meeting, so I'm afraid I'm going to have to also, can we get more time for the Echo Lab? No, I don't think so. I think I need to hold fast on that because I don't want that to spill over into this latest project. Okay, I am out of here.